Welcome to Part 2, covering WebSphere Application Server's topology features. In Part 1, I covered the high points of what topologies are, and this video goes into each in more detail. Since we're still on the basics, we'll continue with things at a reasonably high level. The first topology that we'll examine is the most basic, the standalone application server. This topology consists of a cell, a node, and, surprisingly, an application server. The cell and node are not interactive elements of the topology. They are used for organization and scoping only. For example, some settings apply to an entire cell, some apply to the application servers on a node, and still others apply to a single application server. In a standalone server topology, the application server is the interactive element of the topology. WebSphere Application Server comes pre-packaged with the ability to work with a variety of protocols. Each of those protocols has a corresponding endpoint in a server. Each endpoint is configured to listen on a specific port. The supported protocols include HTTP, SOAP, RMI, SAS, SIP, and more. Each application server defines its own set of endpoints, each of which must be unique for a particular machine. While the standalone server topology does not offer failover, clustering, or other high availability features, it's a robust and popular option. Some customers come up with various ways to create high availability, one of which is to simply put a load balancer in front of multiple standalone server topologies. One of the drawbacks of this approach is you have to manually manage multiple application servers. WebSphere Application Server, naturally, has a solution for this. The network deployment topology is WebSphere Application Server's high availability, clustering, and large-scale management solution. In the first video, I used this diagram to illustrate the ND topology, but it's not entirely accurate. In actuality, the ND topology contains two additional server assets. The first asset we'll cover is the Deployment Manager, or D Manager. It is the administrative entry point for all servers in the cell. Through the D Manager, you can administer resources, servers, applications, clusters, debugging, and so on. It is not an application server itself. Instead, it provides a secure and reliable means to administer the entire cell from a central location. Next, we have the Node Agent. The Node Agent is somewhat unique, both because it is not a user-serviceable server and because you cannot create it manually. Instead, the node agent is created automatically when a standalone application server's node is federated to a deployment manager. The node agent has only two significant purposes. The first is to move information between the D manager and the application servers in the node, and the second is to enable programmatic control over the application servers in the node. Note, however, that the majority of administration is done through the D manager. The node agent is useful for restarting servers and other routine tasks, but any configuration changes to an application server through a node agent will not persist. Next, we'll look at the admin agent topology. This is the diagram used in Part 1, which details the key fact that both the admin agent and the application server retain their own cell node server stacks in separate profiles. Recall that the admin agent acts as a single entry point for administration and management of one or more standalone server topologies on the same machine. Now to expand on how this works. Starting with two separate, unrelated profiles on the same machine, we then register the application server to the admin agent. As with all servers in the WebSphere Application Server portfolio, the admin agent starts with its own set of endpoints, but after the registration is complete, it creates a new set of administrative endpoints specifically for the registered application server. This process is repeated for every application server that is registered to the admin agent. These new endpoints are not a means of accessing the admin agent, nor do they provide access to applications. Application access is still directly through the application server. Instead, these endpoints provide a reliable, secure connection through which to administer the registered server. This arrangement also reduces the memory footprint of the application server, since all management overhead is now delegated to the admin agent process. These and other features make the admin agent a compelling companion to the standalone application server topology. This brings us to the last topology, the job manager. This diagram was used in the first video to illustrate the relationship of the job manager to the other topologies. Like the admin agent, the job manager retains its own cell node server stack and does not participate in registered topologies. What it does do is enable real-time management and monitoring of multiple large-scale and highly distributed topologies. Like the admin agent and the deployment manager, the job manager is not an application server, it is strictly an administrative server. The job manager is so named because administrative tasks are performed by creating jobs. Once created, the job is added to a queue. As jobs are added to the queue, they are distributed to their targets. The target of a job can be either a server on a network deployment topology or a standalone application server topology that is registered to an admin agent. Admin agents are not themselves valid targets, and standalone server topologies that are not registered to admin agents cannot participate in the job manager topology. In summary, WebSphere Application Server provides a variety of topologies out of the box that meet the needs of small, medium, and large-scale deployments. By combining them in various ways, you can increase not just scalability and reliability, but also manageability.